reason
Hello guys, welcome to Cloud Geek Education. Today's lesson is about types of physical quantities. It is our first topic in the BGCSE physics syllabus. We're going to start with general physics. Our first module in physics, BGCSE, is general physics. So we will start with the types of physical quantities. General physics. Types of physical quantities. We have two types of physical quantities, which are fundamental physical quantities and derived physical quantities. One, we have fundamental. Two, we have derived. Physical quantities. Let's explain fundamental. Let's talk about fundamental physical quantities. Let's talk about the fundamentals. There are 7 fundamental physical quantities. There are 7. We have 7 fundamental physical quantities. Which are, we have length, we have mass, we have time, we have current, we have temperature, we have luminous intensity. We have luminous intensity. Last, we have amount of substance. Amount of substance. So these are the 7 fundamental physical quantities. I'll show you guys their SI unit and symbols. Their SI unit and symbols. So let's make a table. Fundamental quantity, SI unit, and symbol. Right? Let's start with length. The SI unit of length is meters. The symbol is M. We have mass as our fundamental quantity. Its SI unit is kilograms. And the symbol is in kg. We have time. Its SI unit is in seconds. And the symbol is S. We have amount of substance. The SI unit of amount of substance is mole. And its symbol is small. We have temperature. The SI unit of temperature is in Kelvin. I know you think it's degrees Celsius, but it's Kelvin. And the symbol is K. We have current. SI unit is in ampere. The symbol is A. And lastly, we have luminous intensity. Luminous intensity. Its SI unit is Candela. Candela, and the symbol is CD. So these are the fundamental physical quantities, their SI unit and their symbols. Let's move on to derived. We have derived physical quantities. Derived physical quantities. So as the word says, it explains itself from the word derived, which means these are derived from the fundamentals. The derived physical quantities are derived from the fundamentals. Derived from the fundamentals. I'll give you 10 of them. We have volume, we have speed, we have force, we have resistance, we have work, we have area, we have velocity, we have acceleration, we have density, and power, and so on. I'm just giving you 10 of them, but we have more of them. So I'll also do the same as I did in the fundamentals. I'll give you the derived physical quantities and their SI unit, also with their symbols. So we have derived quantities, SI unit, and symbol. Right, we have volume. The SI unit of volume is in meter cubed. And the symbol is m to the power 3. We have area. The SI unit is in meter squared. And the symbol is in m to the power 2. We have force. SI unit is in Newton. And the symbol is N. We have resistance. The SI unit is an ohm. And the symbol is this. We have work. SI unit is in joule. And the symbol is J. We have velocity. The SI unit is in meters per second. And the symbol is m per s. We have speed. The SI unit is the same as velocity. It's meter per second. And the symbol is the same. We have acceleration. The SI unit is in meter per second squared. And the symbol is meter m per s squared. We have density. The SI unit is in kilograms per cube. Which is, the symbol is kg per m cubed. Then we have power. The SI unit is in watts and the symbol is W. Symbol is W. So these are the derived physical quantities. We're going to move on, but first let's talk about the scalar quantities and the vector quantities. Let's talk about the scalars and the vectors. So scalar quantities, let's start with scalar quantities. Scalar quantities. Scalar quantities are defined with magnitude only. These are defined with magnitude only. For example, we have time. We have time, length, mass, temperature, etc., etc. Let's talk about the vector quantities. Vector quantities. The vector quantities have both magnitude and direction, are defined with both magnitude and direction. For example, we have acceleration, we have displacement, we have moment, and we have velocity, etc., etc. So these are the scalar quantities and the vector quantities. Let's move on to measurements. This is general physics, guys. Let's move on to measurements. We have 4 measuring instruments. We have 4 measuring instruments. One, we have the measuring tape. 2, we have the ruler or rule. 3, we have the vernier calipers. Last but not least, we have the micrometer screw gauge. The micrometer screw gauge. So the most accurate measuring instrument is the micrometer screw gauge, and the least accurate measuring instrument is the measuring tape or the rule. So that's let me just write you the sequence of from the most accurate to the least accurate, right? As I said, is the micrometer screw gauge, is the vernier calipers, We have the rule and the measuring tape. This is their sequence from the most accurate to the least accurate. Now let's talk about the micrometer screw gauge. Let's talk about the micrometer screw gauge. So the micrometer screw gauge measures a maximum of 2.5 centimeters. It can measure a maximum of 2.5 centimeters. And it's suitable for small length measurements. It's suitable for small length measurements because of its accuracy. It can measure a thickness of a wire, for example. Just trying to show you how accurate it is. So it's suitable for small length measurements. Right. I think that's all you need to know about the micrometer screw gauge. We'll talk about its drawings and stuff in the next lesson. So let's talk about the vernier calipers. Let's talk about the vernier calipers. So the vernier calipers can measure the inside of an object. It can measure inside of an object. That's its special feature. And it measures a maximum of 10 centimeters. It measures a maximum of 10 centimeters. So these are the two features of the vernier calipers you need to know. So let's talk about accuracy of an instrument. Now let's talk about accuracy of an instrument. Let's talk about accuracy of an instrument. Accuracy of an instrument is the smallest possible measurement we can make using the instrument without approximation. The smallest possible measurement we can make using the instrument without approximation. Without approximation. I want you to know this. Instrument with a smaller accuracy is more accurate than an instrument with a larger one. Note this, guys. Instruments with a smaller accuracy is more accurate than an instrument with a larger accuracy. Note that, guys. So let's talk about types of accuracy in centimeters and in millimeters of instrument. Types of accuracy. Let's talk about types of accuracy. I'll draw a table on this one. we were talking about the 4 measuring instrument, but I'll just give you 3 because the ruler and the measuring tape just do the same job. So I'll just give you the 3. The ruler will represent the measuring tape. Let me say type of instrument, accuracy in millimeters, in centimeters, then accuracy in millimeters. Make a table on this one. Right, let's start with the ruler. The rule, its accuracy in centimeters is 0.1 and its accuracy in millimeters is 1. Let's talk about the vernier caliper. Its accuracy in centimeters is 0.01 and its accuracy in millimeters is 0.1. Let's talk about the micrometer screw gauge. Its accuracy in centimeters is 0.001 and its accuracy in millimeters is 0.01. The reason why I'm not putting the units here is because I already put the units here. I think you know the rules when drawing tables. I think you know the rules. So the accuracy in the rule, both centimeters and millimeters will apply in both the ruler and the meter ruler, just like I explained before I drew the table. So that's it for today's lesson. The following lesson and the next lesson, now we'll be drawing the vernier calipers, giving examples on how the vernier calipers works. We'll be talking about the micrometer screw gauge, giving examples on how the micrometer screw gauge works, drawings of these 2 instruments, because I think that the 2 instruments that you guys are not familiar with. So we'll be giving examples showing how they work and stuff. So thank you guys. Meet you guys in the next lesson. We'll be talking about the drawings of these 2 instruments, and I thank you guys.